today we're going to go over hyperbolas, which they have a lot of similarities to ellipses. Okay, they are horizontal hyperbolas and vertical hyperbolas. So I'll make a table for you. The horizontal hyperbolas, the standard form for their equation is x minus h squared over a squared minus y minus k squared over b squared equals 1. So you can see that the equations look a lot alike. It's just that hyperbolas are being subtracted where ellipses are being added together. Okay, and the reason is a hyperbola is the set of all points in a plane so that the absolute value of the difference of the distance between two fixed points is a constant, where an ellipse is the sum. So hyperbolas are difference, ellipse is the sum. So for vertical hyperbola, your standard form is y minus k squared over a squared minus x minus h squared over b squared equals 1. So the way you can tell if it's horizontal or vertical is what variable is positive. When it's horizontal, the x variable is positive. When it's vertical, the y variable is positive. And a is always with the positive variable. Okay, so a is with the x if it's horizontal, a is with the y if it's vertical. A is not always the biggest number like it is with the ellipse. Sometimes it's smaller, okay, but it is always positive. All right, so your hyperbola is a little different. I'm trying not to make it so that it's on the origin. Okay, I want it to be a little bit off the origin for the center. It has two parts to it. It's like somebody took an ellipse and cut it in half and flipped it out or something. Okay, so it's still going to have a center. It's a point right between the two hyperbolas, the two parts, okay? So it has a center. It's going to have two vertices. All right, so this line that connects the two vertices together is called the transverse axis. And the distance from the center to one vertex is A. So that stays the same compared to an ellipse. Okay, then you have two foci points that are just inside your hyperbolas, your two parts. And the distance from the center to one focus is called C. So let's see, then you have this segment, you know, like with the ellipse, you have co-vertices and you have that minor axis that connects the co-vertices. Well, this doesn't have anything for the segment to have endpoints on. It's kind of out there in the middle of nowhere. But you do have this line that is perpendicular to the transverse axis, and that's called the conjugate axis. Okay, and the distance from the center to one of those endpoints of that segment is called B. So it's all, you know, pretty similar to an ellipse. So your center is HK. Your vertices your x value is the one that's going to be changing when you have when it's horizontal, so you're going to have h plus or minus a and whatever k is. Your foci points, h plus or minus c and whatever k is. Then you have the length of the transverse axis is 2 times a, and the length of the conjugate axis is 2 times b. And a, b, and c are all related by a squared plus b squared equals c squared. For an ellipse, you're subtracting the a squared and the b squared, but when it's a hyperbola, you're adding them together. Okay, so one thing that you use to help graph the hyperbolas is the asymptotes. All right, and you get the slopes of the asymptotes when it's horizontal by plus or minus b over a. There are 2 of them. They always go through the center. So if you can plot the center and then count your asymptotes out and use those as guidelines, plot your vertices and then use those asymptotes as guidelines to draw your hyperbolas. And we'll do one together. But the asymptotes go through the center and they are drawn as dotted lines. Now on your notes at the bottom, there is a typo when it's talking about the equation for the asymptote. The equation for the asymptotes, since it's a line, when it's horizontal is y minus k equals plus or minus b over a times x minus h. So on your notes it doesn't have the k with your y, so you can either just mark that out or correct it. So if you notice your slope for the asymptote is b over a, and b is with the y. So that's how I kind of help myself remember what the slope is going to be, because the number that's on top in the numerator is always going to be the one that's with the y. All right, so for your vertical hyperbolas, you just rotate your horizontal ones 90 degrees, right? And there's your vertical. All the parts are the same. None of that's going to change. So your center is HK. The vertices, since it's vertical now, the y value is the one that changes. So that would be H and K plus or minus A. Your foci points, again, the y value is the one that changes. And that's H and K plus or minus C. Then your transverse axis is still 2 times A. The conjugate axis is still 2 times B. You still have that A squared plus B squared equals C squared. They're all related that way. Your asymptote now that it's vertical and the bigger value is with the y, a is with the y, that means that your slope is going to be plus or minus a over b. And your equation for the line, for the asymptote line, y minus k equals plus or minus a over b times x minus h. So that one on your notes doesn't have the k either, so you need to change that. Any questions on that? Let's do some examples. Let's look at number 1. It says to find the coordinates of the center, the vertices, the foci, and the slope of the asymptote. Now, number 1, You don't have any variables to the first power. Both of them are squared. So what that means is you don't have to complete the square. Your center is going to be at the origin. Your HK is 0, 0. So this one will be kind of easy to work with. The only thing you need to do to get this in standard form is set it equal to 1. So that means I need to divide everything by whatever the number is over here. In this case, it's 36. So I've got to divide everything in the equation by 36. And I wind up with x squared over 36 minus y squared over 1 equals 1. Okay, that gives you a is 6 and b is 1. And to get c, I'm going to have to use the a squared plus b squared. Okay, a squared is 36, b squared is 1. That's going to equal c squared. So 37 is c squared. That means that c is going to be the square root of 37. Okay, so my center is at 0, 0. And the vertices, now since my positive value is x, that means it's going to be horizontal. So if it's a horizontal hyperbola, my x is going to change for the vertices. So that's going to give me 6, 0 for one vertex and negative 6, 0 for the other vertex. And the foci points, the x value is going to change for that as well. You're going to get positive square root of 37 and 0 and negative square root of 37 and 0. And then your asymptote slope, and we're going to graph this one too. Is 1 over 6, plus or minus 1 over 6.